This video will provide an introduction to electrical testing and fault finding. Within this unit, we will consider four primary types of fault: short circuit, open circuit, component polarity, and component value. During your career, you will come across many other types of fault. However, these are some of the most common. The boards used for the fault finding assessment will only have these four types of fault on them. Short circuit. A short circuit is an electrical connection between two or more points. These points can either be component pins or tracks on a PCB. On PCBs, the most common cause of short circuits are solder or wire connections between pins or connections between tracks caused by manufacturing issues. Short circuits can be identified either visually by comparing the constructed circuit to the schematic and routing diagrams, or by using electrical tests such as the continuity test. Not all short circuits may be bad. For example, if two pins have been connected together by a blob of solder, it's important to look at the routing diagram or schematic to see if they were already electrically connected. In this example, the two pins of the capacitors C1 and C2 are connected together by a blob of solder. By looking at the circuit diagram, you'll be able to see that these pins should both be connected to ground anyway, and so the solder is not actually causing a problem. It may have been added if the track between the two pins had been broken, and it was used to fix the track. Open circuit. An open circuit is when two points which should be connected are not. This could be due to a pin not being soldered onto a PCB or a break in a track. As with short circuits, open circuits can be identified either visually by comparing the constructed circuit to the schematic and routing diagrams, or by using electrical tests such as continuity test. Open and short circuits are not always unwanted. For example, a switch can either be an open circuit or a short circuit. Component value. A component value fault occurs when the correct type of component has been used, but the value is wrong. For example, a 10k resistor may have been used instead of a 330 ohm resistor, or a 1 microfarad capacitor instead of a 1 nanofarad capacitor. Component value faults can be found either by doing a visual inspection and reading the values of the components, comparing them to the schematic, or by electrically measuring them. For example, this middle resistor here is R9, which should be 10k. By reading the colour code, you can see that it has a value of 10 megaohms and is therefore incorrect. Component polarity. A component polarity fault is where a polarity-sensitive component has been placed in the wrong orientation. For example, LEDs or SIL resistor networks placed in backwards. Polarity faults are usually found by doing a visual inspection, looking at the component and comparing it to the datasheet and placement diagram. They can also be found by electrically measuring them. In this example, you can see that this LED here has been placed in the opposite polarity. Sometimes components can be in what look like polarity-sensitive packages, however it doesn't matter if they are placed in the wrong orientation. For example, resistor networks RN1 and RN2 are in DIL packages, which can often contain polarity-sensitive circuits. If we look at the datasheet and schematic, we can see that the resistors are connected to pins on opposite sides of the package. This is the datasheet for the DIL resistor networks. You can see that they are pass-through on pins on opposite sides of each other. As all of the resistors are the same in the package, if we placed it in backwards, such as the example on the right, there will be no electrical consequences. The only consequence is the aesthetic look of the board. Electrical testing. The purpose of electrical testing and fault finding is to identify if a circuit works, and if it doesn't, where the fault lies. Testing should be conducted in a systematic way, where each part of the circuit is tested independently if possible. This approach reduces the likelihood of missing something. Initial testing should be a two-stage approach: visual inspection followed by electrical testing. Visual inspection. Visual inspection is probably the most important test you will conduct, and should be undertaken before any power is supplied to the board. Many faults can be identified visually. The purpose of the test is to ensure that all components are present in the correct location, placed in the correct orientation, and have good solder joints. You should also be able to identify any obvious short circuits or open circuits. Visual inspection needs to be performed on both sides of the circuit, in conjunction with the schematic diagram, placement diagram, and routing diagram. Once you've completed the visual inspection, you can make a start on the electrical testing. There are 3 standard measurement tests and 1 indicator test you can do: voltage, current, resistance, and continuity. Voltage measurements. Voltage measurements are done in parallel. Your test probes can be placed on either side of the component you are measuring across. For this unit, all voltage measurements will be done with reference to 0 volts, so the black probe is always placed on a 0 volt connector. The red probe is placed on the other side of the component. Here we are going to measure the input voltage to the test board, which should be 5 volts. We will place the black probe in the 0 volt connector and the red probe into the 5 volt connector. We can map the schematic for this circuit to the real-world version as we did in the schematics and datasheets lecture. Here is the power supply, 5 volts. The positive side is the red wire, which is this line here. The voltmeter is the multimeter here, which the red wire goes into. The black wire comes out of the other side and into 0 volts, which is this line here. It is assumed that the impedance of the voltmeter is infinite, so the current drawn through the circuit is 0. This means that we can ignore the effects of the current limiting resistors in the circuit. Current measurements. Current is measured in series, and you need to physically break into the circuit to measure it. This could be as simple as replacing a connecting wire. Here, we are going to measure the current being drawn by the test board. Conventionally, current is measured on the positive wire. We are going to insert an ammeter in series between the positive connection from the power supply and the test board 5 volt. We can map the schematic for the circuit to the real-world version as we did in the schematics and datasheet lecture. Here is the power supply positive line, which is connected via the red wire to the ammeter, which is this connection here. The other side of the ammeter, the black wire, goes back into the positive side of the power. This is then connected to the load and then back to the negative side of the power supply. You will notice that when the test board is connected, there is a small current draw. This is despite nothing being activated on the board and no I/O board connected to it. This is essentially the background current drawn by all of the components on the board and is known as the quiescent current. For the I/O board, the quiescent current is between 1 and 5 milliamps. If you get a reading higher than this, it indicates that something is drawing current which shouldn't. It won't tell you the location, it will just indicate that there is a problem. The main quiescent current contributors are the switch circuits, depending on the position of the switches, the LDR, the potentiometer, the temperature sensor, and the capacitors. Resistance measurements. The third measurement test you can do is a resistance measurement. To perform this, you need to ensure that the board is not powered and remove any connections made to perform other tests. If necessary, you should desolder the resistor from the board before measurement. This may seem a little drastic, but resistance measurements are done by injecting current into a circuit and measuring the corresponding voltage. The multimeter then calculates the resistance. Unfortunately, current will flow wherever it can, so it may flow through other resistors, which will affect the final calculated resistance. Continuity test. The continuity test, or beat test, is used to check if 2 points are connected electrically. If there is a connection, the multimeter will make a sound. If there is no connection, there is no sound. This test can be used to identify short circuits or open circuits.